Good day everyone. Welcome to another tutorial. Today we're going to discuss about graphing polynomial function. This is a two-part video and this will be our part one. So let's start. In this lesson we're going to tackle about a four components on how to or four things that we need to do in order for us to graph a polynomial function. First is we need to know how to identify the end behavior of the graph, how to get the x and y intercepts, to count how many turning points, and to discuss the concept of multiplicity of roots or zeros. So let's start with the end behavior of the graph. We have this what we call the leading coefficient test. In the leading coefficient test, we test the leading coefficient of a certain polynomial function or a polynomial function, and it tells us the end behavior of the graph. If the leading coefficient is positive with an even degree or even degree, meaning the exponent of the first of the variable or the degree of the variable of the leading coefficient, the graph rises to the left and rises to the right. So, meaning we have a graph that rises to the left and rises to the right. On the other hand, if the leading coefficient is negative, it has a negative sign, with an even degree, the graph falls to the left and falls to the right. So again, if it is positive, it and even degree, it will rises to both left and right. And if it is negative and it has even degree, it will falls on both left and right. Now, on the other hand, if the leading coefficient is positive and with odd degree, the graph falls to the left and rises to the right in this manner. On contrary, if the leading coefficient has a negative with an odd degree, the graph rises to the left and falls to the right. So this is a table to summarize the end behavior of each condition. Even positive is this, even negative is this. A clue there, if it is even, the end behavior will both rise or will both fall, def depending on the sign of the leading coefficient. If it is odd, it will goes like this. Add negative like this. Okay, to illustrate that in a graph, we have this illustration. This is rises to both left and right. This one is even negative. This will falls on both left and right. Odd positive rises to the right and falls to the left. Then this rises to the left and falls to the right. Odd negative. So now let's try to check our knowledge about this. In number one, let's determine the end behavior of this graph. In x raised to 7 plus 8, x raised to 4 minus x raised to 3 and minus 8, our leading coefficient is this. Our leading coefficient is 1 and this is positive. This is positive, then we have positive odd. So if it is positive odd, then the answer is falls to the left and rises to the right. For number 2, let's check if it is in standard form. It's in standard form. So meaning this one has a negative leading coefficient and an odd and an even exponent. So therefore, it will falls to both left and right. Number 3, we have our leading coefficient. It's in standard form again. And our leading coefficient is this. We have negative and odd. So if I have negative and odd, it will rise to the left and falls to the right. For number 4, we had 6. 6 is even and it is positive. So therefore, that will rises to left and rises to right. So that's all for our end behavior. Now let's proceed to x and y intercept. X and y intercepts are used to determine the points where the graph intersect or touches the x-axis and the y-axis. In this illustration, as you can see the graph, this graph, they touches or intersects the y-axis at point 0.06 and it intersects the x-axis at point -4, 0. In simply saying, the y-intercept is the value of y when x is equal to 0. And x-intercept is the value of x when y is equal to 0. So that's the x and y intercept. Another illustration is this. As you can see this graph, it has y1 intercept. This is the y-intercept. And these two is what we call the x-intercepts. So these are the values of x when y is 0. Okay? So the problem is in how to find that. How to find the x-intercept of the polynomial function. So remember, factor the polynomial completely and set y to 0. So equate each factor to 0 to find the value of x. It's just like factoring the polynomial function, and let's equate each factor to 0 and find the value of x. Note note that lesson about solving polynomial equation or function will help you in finding the x-intercept. So if you know how to solve polynomial equation, you need to go back on that lesson or on that tutorial and equip yourself with that tutorial, with that knowledge, so that you could easily do the x and y intercept. For the y-intercept, we need to set the value of x to 0 to find the value of y. So let's consider these two examples. Let's find the x and y intercept of the following polynomial function. Let's go with the number 1 first. Let's solve for x-intercept. Now, we will use syntactic division to find the x-intercept of this. Again, I draft the coefficient here. I just get the coefficient of all the terms. We have 0 here for x raised to 2. We have 0x raised to 2. We just fill that out. And I will test a factor of 6 divided by the factor of 1. So just go back to the rational zero theorem to get the list of all the possible roots of this polynomial. So in this case, the factor of our leading coefficient is 1, so that's positive negative 1. And the factor of 6 is positive negative 1, positive negative 2, positive negative 3, and positive negative 6. Then divide this by this, positive negative 1. So the answer will be positive negative 1, positive negative 2, positive negative 3, positive negative 6. So let's choose from this number to test. Let's choose a number here to test whether if it is a root or not. In this case, I will test 1. So I will bring down first 1, then 1 multiplied by 1. That is 1, the answer here. Then combine. Then we will bring down 1. Then 1 multiplied by 1, the answer is 1 as well. Combine this one, negative 7 plus 1. That is negative 6. 1 times negative 6, put the answer here. The answer is negative 6, and we add the 0. So we need to find a number that will give us a 0 remainder. Meaning this is a solution and this is a factor. So this is a value of x where if which if I substitute here, the answer will equal to 0. So what if I test a number that doesn't equal to 0? Then cross out that number and test a number again. So in this case, after I get this 0, I just use this. Maybe I could just put x squared here, x raised to 1 here, and x raised to 0 here. Or if I simplify it, x squared plus x minus 6. If I know how to factor it using quadratic this quadratic equation, I can do that. But for the sake of those who are having hard time to do that, let's just continue, bring this down and continue using synthetic division and testing all those numbers. From this time, I will test 2. I will bring down 1. 2 times 1 is 2. Combine it. 3. 2 times 3 is 6. And that gives me 0. Now for this time, we can use synthetic division here, but it is easy for us if we just transform it into x plus 3 is equal to 0. Well, that's the case for here. This is x raised to 1, this is x raised to 0. So if we simplify this, we have x, and if we simplify this, we have 3. So that is x plus 3. Then we subtract 3 on both sides, and we get x is equal to negative 3. So this 3 is the value of our x, the values of our x. So that is 1, 0. This is the x-intercept. 2, 0. And negative 3, 0. Also, since this is the values of x, we can write this equation into this equation. Or x minus 1, this for this, x minus 2 for this, and x plus 3 for this. Now, if you're going to multiply it, you will get a product of this. So this 2 is the same. So if we equate each number to 0, then we will get the values of x. So that is, these are the values of our x. Okay? Now let's solve for y-intercepts. Now again, y-intercept is the value of y if our x is 0. First, let's equate the polynomial to y. Then let's set x to 0. Then if we evaluate this, this will be 0. If we evaluate this, this will become 0 as well. So that will become y is equal to 6. So therefore, our y-intercept is 0, 6. Okay, for number 2. Again, we just use the synthetic division and test all the possible roots. And after we test all the possible roots, if we get 0, then this one is a root or a factor. So x minus 1 is a factor. Then let's test another one. For this, negative 2. Again, you will just use this one to test the second factor. So we have this, and it gives us 0. Then this will become x plus 3. Then if you minus 3 both sides, you will get x is equal to negative 3. Then we have this as our 0. Okay, this will be our zeros, and that will become our x-intercepts. Now for y, all we need to do is to set the value of x to 0 to find the value of y. So this will give us 0, 0, and 0. So the remaining is negative 6. So the value of y is negative 6. So we have a y-intercept of 0, 6. So these are all for how to get the x and y intercepts. Now let's proceed to turning points. Now the number of turning points is at most n minus 1, where n is the degree of the polynomial. Meaning, if these are the turning points, the number on how many times the number will turn. Meaning, just take note of the term at most. If the degree is somehow 5 minus 1, then we have 4 at most turning points. Meaning, lower than 4 but not greater than 4. That's what the meaning of at most. Lower or equal 4 but not greater than 4. So for linear, we know that a linear function has a degree of 1. So 1 minus 1 is 0. So therefore, there is no turning point for a linear function. So that's why it is a straight line. For a quadratic function or quadratic equation are functions and equations that is in second degree. So meaning 2 as the degree of the polynomial minus 1 is equal to 1. So therefore it only has one turning point. So its graph is a parabola like this or like this. For a cubic, when a cubic function, the highest degree for this function or the degree of this function is 3. So 3 minus 1 is equal to 2. So that's why it has two turning points. It could be written like this or it could be written like this. Two turning points. Now let's tell the number of turning points of the maximum number of turning points of the following polynomial function. So for number 1 is 6 because 7 minus 1 is 6. For number 2 that is 4. The degree is 4 minus 1, that is 3. On number 3, the degree of this polynomial function is 3. So that makes it 2. 3 minus 1 is 2. And this is 6. 6 minus 1 is 5. So again, this number are the maximum. Meaning, it could be this number or less than this number. But not greater than this number. Okay, we're done with multiplicity. Now let's go with Oh no, we are done with the end turning points. Now let's go with the multiplicity. Okay, the multiplicity of zeros is the number of occurrence of these zeros in complete factorization of a polynomial. Again, we need to find the factorized form of polynomial and see if there are zeros who occurs more than one of it. So it has a multiplicity. So the factors, the number of occurrence will affect how do we graph it. So if it occurs an odd number of times, meaning there is a one number or there is a certain root that occurs on odd number of times, meaning one time, three times, and five times odd, that the graph of that the graph of that point or that value will crosses the x-axis at that zero. If it occurs an even number of times, maybe there's a 1 0 that is twice, four times, or six times that appears in the factor, then that graph will just touch the x-axis and it will just bounce back at that zero. So example of the factorized form of polynomial. Now as you can see, the value of x-intercept here is 3, 0 because we equate it to 0. The value here is 2, negative 2, 0, and here is negative 2, 0. See how this 0 appears only once and this 0 appears twice. Meaning this 0 will pass the x-axis at point 3, and this 0 will touch the x-axis at point negative 2, 0. This is positive 3, 0. Let me illustrate it to you. Let's try this polynomial. If we're going to factor out this polynomial, we could use common monomial factor to single out this. Now, to factor this out, this is a perfect square trinomial. So if we factor that out, we will get this factor. So this is written like this, but actually it is written, we could write this as like this. So the value of x here is 0. So that is x is equal to 0 with multiplicity of 2 because they appear twice. On the other hand, the factor of the value of x here is positive 3 with multiplicity of 2. So if we're going to plot this in a graph, we have 0. This is the point of 0. Okay, we'll mark it down. And 3, 0 here. 0 and 3. Now let's check the end behavior. The end behavior is 4, positive. So maybe the end behavior is like this. Now it's time for us to connect the dots. If it reaches these zeros, because the multiplicity is even, then it will not cross the x-axis. It will just bounce back and turn again, and it will just bounce back. Again, this bounce back because 3 has a multiplicity of even number. So the rough sketch of this graph is like this. Now let's see how many turning points we have. We have 4 here. This is understandable. We have 4. So meaning we have 4 minus 1, that is 3. We need to have at maximum of 3 turning points. Then how many turning points do we have here? 1, 2, and 3. We have 3 turning points. So that suits this equation. Okay, and our end behavior is also correct. Positive odd, a positive even that gives us rises to the left and rises to the right. So that's how to factor it. To illustrate it more, if we have a single zero, meaning a zero that has that occurs only once, it just passes the x-axis. It just passes the x-axis. But if the multiplicity is 2, it will just bounce back. And if it has multiplicity of 3, it will pass the x-axis, but it will somehow flatten before it reaches 0. See the difference between this one? These are both odd multiplicity. If it is 0, it just goes straight. But if the multiplicity is odd and greater than 1 occurrence, then it just flatten before it crosses the x-axis. Here's another example. X minus 1 is equal to 0. So let a be 1. So the value of x here is equal to 1. So that is 1, 0, the x coordinate. So this is 1, 1, 0. It just pass it through there. And this x is equal to 1, multiplicity of 2, because they are 2. Then it bounces back. It touches the x-axis. Then this one. It crosses the x-axis, but it flattens before we reach the zeros, and flatten again before it leaves the zeros. Now before we end this, let's just make a rough sketch of a graph of this polynomial function. So first, let's list the x-intercept. We already solved the x-intercept of the following functions a while ago, and we also solved the y-intercept of this. All we need to do is to plot all the points that we know. I put 0, 6 here because we only have 1, 2, 3, 4, 5, and 6 is here. I just assume that 6 is here, and that's one. Now let's look at the end behavior. This is positive odd. If it is positive odd, then it will falls to the left and rise to the right. Okay, now let's try to connect the dot. Now remember, we don't have any multiplicity. That's why it will cross the x-axis on all the x-intercepts. So this 3 will give us a maximum of 2 turning points. That's why we have 1 and 2 turning points here. So this is the rough sketch of the graph. Okay. And now if we use Desmos, we will get this as the sketch of the graph. It's condensed because I want you to see this is by 10, 0, 10, 20. So maybe the points here will be -3, 0, -0. This is 1, 0, 2, 0, and this is 6, 0. So these are the points. And the end behavior is like going here, and going here. Falls to the left and rises to the right. And we have two turning points. Okay, so this is the actual graph. One before what I made is the sketch, rough sketch. Okay, let's make a rough sketch of this. We already solved for the x-intercepts of this and the y-intercept as well. So all we need to do is to plot all the points. So this is 0, 6. My graph is so we have again it will positive 3, no, positive and odd. This will falls to the left and rise to the right. Just connect the dots and you give us a rough sketch of this. Oh, let's rewrite this. So again, it has two turning points and we have the right and behavior. Okay, so if we're going to use Desmos or other graphing calculator, you will give us this graph. Okay, so I hope you learned today, and I want to say thank you for listening to my video until this time. Hope you learned something and hope you share this to your friends and ask them to subscribe and like as well. That's all for today. Bye bye.